Mechatronics department. So once again, Yuva Kshetra College and especially Department of Computer Science extending the thanks and the concern towards Jyothi Engineering College for sharing their valuable time with us in order to improve the skill set of Department of Computer Science students in Yuva Kshetra College. So once again, thank you from the part of Yuva Kshetra and the Department of Computer Science. And I welcome Dr. Karthik to handle the session, 11th session of Sensors and Transducers. Welcome you, sir.
Thank you, ma'am. Thank you for welcoming. Very good afternoon all again. We are meeting again for this wonderful session. So let's continue for this. And before that, we just remind something what we discussed previously in the case. So basically, level measurement that we discussed earlier is measurement of a position of two phases which interfaces in a closed manner, right? It may be solid or liquid phases which are interfaced, and the position is measured by means of a kind of sensors. So called the level measurements, or those sensors may be called it as a level sensors. So that we basic thing that we discussed, and among them the major thing that we must to consider is these are the thing, whether we're going to measure in an open tank or closed tank systems, or can the level sensor be inserted into the tank, or should it be completely external? Will be called it as a contact or non-contact type of measurements. We need continuous or point measurements, since for many cases only the indications is required. Those places we don't need of continuous measurements of a level, right? Maybe for alarming systems, for indication systems, we need point measurements, that's so-called discrete measurements of levels. Either it may be high or low or medium. But some of the cases we need, in most of the industries, we need to measure the level of a particular, maybe a fluid or a gas or a solid particles. We must measure in continuous manner, so that the applications what we chosen is either going to measure continuously or point or discrete type of measurements, and either direct or indirect measurements. So direct measurements, as we discussed in the last class even, direct means there is only the mechanical portions, there is no need of conversion into an electrical, and there is no need of any displays required. So whenever the display is required and we need to do some recordings, then we must convert the physical parameters like a level, maybe in centimeters or meters, that need to be displayed in a computer or any digital displays, or further we need to do some control actions. Then in such a cases the indirect measurements is required, and there is no mechanical part alone, there is a mechanical part with an electrical part. The combinations will give the real parameters into an displayable parameter, right? So the applications should be either direct or indirect measurements. And last, whatever material is being measured, either it may be a liquid or a solid or a gas. So these are the major criteria to be know before going to select the sensors. It may be for levels, not only for the level sensors, it may be used for different, all the major parameters that we discussed previous cases. Four important or primary parameters, or level, pressure, temperature, and flow. These are the more primary parameters, and supplementary parameters also be there. A lot of supplementary parameters like viscosity, density. So many of the parameters are there to measure, to provide a desired outcome of a particular industries, right? And in this case, these are the important thing why I'm discussing behind this. So based on which only we have classified the sensors or transducers, and we discussed regarding about direct and indirect methods, And if it is a direct, either we can measure continuously or discrete measurements. Even though with a measurement of indirect type, we can do either continuous or point measurements. And these, everything is interrelated. Either the measurement is going to be conducted with the fluid which is inside the tank, or there is no contact is needed. So contact or non-contact type.
Excuse me, sir.
Yes.
Are you presenting some screen?
Yeah.
No, it's not visible, sir.
Okay. I'll share again. I think. It's okay now?
Yes, now it's showing.
Okay. That's
Okay,
fine.
you can continue.
Yeah. So don't know about that, these things that we discussed earlier itself. And after that, we discussed about direct measurements. With the help of a side glass, flow type, and dip disc. These methods. And inferential method also we discussed, like a hydrostatic method. Hydrostatic in the sense it's a height of the liquid column. Maybe call it as a pressure head. So pressure head is nothing but a height of the liquid column. So mass measurements, in the sense we cannot able to measure the height directly. That is also belongs to a inferential method, right? That is also belongs to an inferential method. See here. And here we cannot able to measure some kind of fluids which we were used in chemical industries or some other major industries. We cannot measure it with the help of direct measurements like float or other side glasses. So that time what we supposed to do, we measured in terms of measuring the pressure or mass or weight, right? And if we indirectly measured and we correlate those measurements in terms of level, that may call it as a inferential measurements. Inferential in the sense we are supposed to measuring the pressure and we just correlate into a pressure in terms of pressures. So see here, the best thing is the relations between the height, pressure, and density is there. So our objective is to measure the height of the tank, right? Either we may use the water. Here going to measure the level of the water in the tanks would be measured, and how they are relating here. See here, height which is equal to 1.8 psi divided by 10 density. So in this case, we measuring the pressure. So pressure may be high at the bottom of the tank. So once we measure by means of a pressure measuring instruments, either it will be a bellow gauge or diaphragm gauge, that you might know about that pressure measurement devices in previous sessions, I think so. So in such a way that, see here the relationship height, pressure, density. So among them, either we can measure the height in terms of by means of pressure, or maybe a density of the water that can be used to measure the height of the water tank. So we cannot measure directly the height of the liquid. So we are measuring either pressure or density. So that measurements infer the measurement of a level, so that it may be called it as an indirect method or inferential measurements, right? Either we can measure the pressure, or we can measure the weight of a tank, or weight of the liquid. How they are doing, in the sense, you might know about the weighbridge methods, right? Weighbridge, everywhere that you might see the weighbridge, they used to measure the weight of the vehicles, maybe a loaded vehicle. What they are supposed to do, they are measuring the weight of the vehicle before loading it. That means unloaded vehicle is measured, and after that they are measuring with the load. Then they subtracted the loaded vehicle with an unloaded vehicle, so that we can get the mass of the material which is loaded, right? In such a way that what they're supposed to do in mass measurements of level, they just measure the empty tank of where we going to fill, or where the fluid going to be filled, or a gas or solid it may be. All right, based on the applications we can decide it. See here, I think it's very visible to you all. This is a weight-based level measurements. Here, what we supposed to do? Here, the tank, in between there may be, I think there is a gap. You might see in that gap there is a sensor, so-called strain gauge. Strain gauge is a sensor which is used to measure the weight or strain of a particular parameter. I mean, particular applications. It based upon the principle of piezoresistive effect. Piezoresistive effect is nothing but it's very simple. So when force is acting on a particle, then the particles get some differences in their structure. Either it may be a extraction or contraction of the structure, as well as the physical or electrical properties of material. I mean, the material, if it is a piezo material, then because of the properties of the material, when you apply the force, here what I am supposed to say, the force is the weight of the tank. So normally weight of the tank, it's when we kept the tank over the strain gauge, then what happened? The force will be act on the strain gauge. Strain gauge is a device, normally a device having the property of piezoresistive effect. That means it's a resistive material. The property of resistance is changes when force is acting on it. So generally, it works on the principle of electrical conductance. It may be called it as an electrical conductance, and it depends on the conductor's geometry. Whenever the conductor is stretched within the limit of elasticity, what I'm trying to say here is, see some, for an example, you're supposed to take a rubber eraser, right? Eraser. So when you push the eraser, what happens? The geometry position of the eraser may be differ, right? That means it may be extend or it may be contract based upon the applications of the pressure and the side of the applications of the pressure or a force. So what happens if it is a resistive material? Then the geometry position will cause us the changes of the electrical property. Either basically the electrical properties are either three things. Either it may be resistance, or it may be a capacitance, or it may be inductance. So if any force on any material provides an electrical changes, then those materials are called piezoresistive material, and the resistivity of the material is causes changes in the electrical voltage. So this is a basic thing of strain gauge. Here what they're supposed to do, in between, you might, if you notice there may be a gap they provided. In between what they have fixed one strain gauge sensor. So there is a basic strain gauge sensor. When there is no fluid filled on the tank, and because of that there is a change in the strain gauge is measured previously. What weighbridge is doing, the same thing in weighbridge itself, they are using a strain gauge to measure the force, right? It may be a force or mass. We can call it as we might see weighing machine, right? Weighting machine in different places also. There is a strain gauges. When you supposed to be stand on it, then the force, your force will be act on the strain gauge, causes the changes in the resistive value of the material, which causes the electrical output, right? and the changes in the electrical output is directly proportional to the application of the force. That is the basic concept of the strain gauge. Here, without any fluid, the tank weight is measured. The tank weight is measured and it is kept right aside. And what they do again, they are started to fill the tank. Then the height of the water column inside the tank will create a more pressure or force on the strain gauge. So strain gauge is here. Then the changes in the electrical resistance will give them some electrical quantity of output. So these changes, which is correlate in terms of height of the liquid, that is the method of mass level measurements or weight based level measurements. So here the weight based level instruments, which senses the process level in a vessel by directly measuring the weight of the vessel. So here what we are measuring, the weight of the vessel, right? And this weight of the vessel which infer the measurement of a level, so that it may be called it as a inferential method or indirect method of level measurements. It is a weight based or mass level instruments. If the vessel is empty weight, we may call it as a tare weight in industries, right? Is known. And process weight becomes a simple calculation of total weight minus tare weight, right? So previously, we might know about the tare weight, empty weight of the tank. And for passing the liquid or pouring some solids or filling the gas, whatever it may be the material, we don't bother about that. We want to measure the height of the tank, filled medium. Then when the height is increased, the weight of the tank also be increased, right? Then there may be simple calculations by subtracting the total weight with the tare weight. Then the remaining weight is directly proportional to the height of the medium inside the tank. So that is the concept of indirect method of weight-based level measurements or mass-based level measurements. Here weight is measured. Here weight is measured, and which is correlated with the level of the tank. So based on this, we can measure the height of the liquid, right? So weight-based level sensor can measure both liquid and solid materials, and they have the benefit of providing inherently linear mass storage measurements, right? We can measure the liquid, or we can able to measure the solid even. So many industries, solid also to be measured. Sometimes, for an example, I can say that bottle filling systems, if you consider bottle filling systems, the water bottle, how they are filling exactly in the same quantity, in the sense either they provided the timings, right? So time to open, time to close, they fixed. Once the bottle is coming below to the nozzle, then the timer will start. Otherwise, another method what they are doing, there may be a strain gauge or weight-based sensors. Weight-based sensor is provided, and the weight is monitored continuously. The weight is monitored continuously when the fluid is coming out from the nozzles to the bottle. I'm telling about aquafina or something, right? We're going to fill the water inside the bottle. So what they're supposed to do, they are filling the water inside the bottle, and they are measuring the weights, and they fix the weight ranges. If the weight of the bottle is coming exactly or which is equal or very near to the weight of the described value, then the bottle filling was stopped. So there may be two methods, by means of timings or by means of weight measurements. So there also that weight, the height of the or filling of the water inside the bottle can be measured by means of the weight of the bottle while filling itself, right? So that is so-called mass-based or weight-based level instruments. I think you might understand the concepts here. See here, there is a three tanks are provided, and here it may be influenceable liquid, so that we cannot measure directly the level, or even by means of a pressure, even we cannot able to measure. So in such a cases, they provided these methods. I mean, strain gauge. They are arranging the strain gauge in between the pillar and the tank, and when the water is filled, the force is acting on the strain gauge causes corresponding electrical output, and this electrical output is directly proportional to the level of the tank. So this is the inferential method. And next is an electrical method. So electrical method is different type of electrical method. Even we can say that previously strain gauge is another electrical methods. Strain gauge is another electrical method. Their electrical output is considered to measure the level of the tank. And another type of measurement is capacitive type level indicators. So capacitive level transducer is a best example of indirect measurements. Here the capacitance level sensors are often used for wide variety of either solids or aqueous solutions or organic fluids and slurries. The techniques is frequently referred as RF, radio frequency techniques. Since in the capacitance probe, there is an radio frequency signal is applied so that the capacitance will be enabled. So RF signal is applied to the capacitance circuits. The sensors which can be designed to sense the material with dielectric constants as low as either maybe a coke or a fly ash, as high as water, right? And the basic working principle is purely depends upon, we know that the basic physics, capacitance is directly proportional to the epsilon or K A divided by D. This is a basic physics, right? How their capacitance are measured. So where K is the dielectric constants and A is the area of the plates and D is the distance between the two plates. So capacitance, in the sense, there may be, capacity. For an example, if I say what is the capacity of this bottle, in the sense it may be closed, right? It may be closed. Likewise, if it is a capacitor, there may be closed things should be there. And two plates are there. Generally, the construction of the capacitor is there is a two plates. In between there may be a storage of electricity, so-called capacity, right? Capacity or capacitance of the electrical properties, we can say that. So there is a two plates, or more than two also we can say that. We can say that are the more than two, more than one. It's an exact thing. So more than one, either it may be a two-plate capacitor or three-plate capacitors, whatever it may. So if let me consider the two-plate capacitor, there is a two-plate capacitor. In between there is a electrical charges stored. So by applying the electrical property, either a current, right? So in this case, how it can be used to measure the level? The principle of operations of capacitance level indicator is based upon the familiar capacitance equations of a parallel plate capacitor, the dielectric constants. So let's assume there is a two plates which is connected with the electrical supply, right? And each plate has its own area, and in between the two plates there is a medium, so-called dielectric medium. Between either it may be air or it may be water or vacuum, whatever it may be, right? Most probably it may be air or water. In this case, if we want to measure the level of the tank, then we must to use the medium as the liquid which is going to measure, right? And third one is a distance between the two plates. So you are just keeping, I can show you, then you can understand. See here, in this sphere, so there is a tank. I'm going to measure the level of this tank. Water is inside, And what I'm doing here, there is a proof I have provided. Either it may be any places, either it may be here or center, or it may be very near to here. And as I said, capacitance, in the sense there may be two plates. Here the outer body is a one plate and the probe is act as another plate. So there is a two plates, and the medium I'm here using is a water. So water is a dielectric medium. Right, now let me go to the basic principle. Here, whenever the capacitance, any changes in the dielectric medium or area of the plate or distance between the plates, then there is a changes in the capacitance. So this is the basic physics concept. So that can be used for measurement of the level, how it can be, right? So our objective is to make any properties in terms of electrical quantity to measure whatever it may. Either we can measure a pressure or a level or a flow, whatever the field measurements, if we have possibility to convert into electrical quantity the measurement, then we can try to correlate the electrical measurement in terms of the physical quantity, right? For an example, level of the tank, the sense I need some electrical quantity to represent in terms of electrical output, right? Here, the major electrical properties are either capacitance or resistance or inductance. In previous case, what we discussed is a weight-based measurement. There is the output is a resistance changes. Here, the output is a capacitance changes. So, if you want a compact electrical output, exact measurements, is there any possibility to convert the physical quantity into electrical quantity? Then it is possible to measure anything. It is possible to measure anything. But we must know the method of getting the physical quantity in terms of electrical output. So here what we are supposed to do, we can either changes the dielectric medium or changes the area of the plates or changes the distance between the two plates. So as I said, let assume these two will act as a capaciting plates. So here area won't be changes, right? Area won't be changes. The possibility is the dielectric medium. Here these two parts will be act as a plate. These two parts will act as a plate. When now there is no dielectric medium, air is a dielectric medium. So when the level is increased, to it comes in between, then what happens? The dielectric medium is changes. So these dielectric medium changes, as we know, changes in the dielectric medium causes changes in the electrical capacitance, right? So it may be used for continuous measurement as well as the discrete measurements. Here, if you fix the capacitance plate here itself, measurement of the tank, when it is at high position, then it will be act as a point measurement or discrete measurements, right? So whenever the liquid is come here, then there may be connection between the changes in the dielectric medium, and causes changes in the capacitance, and the capacitance is correlated matches with the height of the liquid tank. Here what happened? Here the signal will be enabled. The signal will be enabled and it is given to the corresponding control or indications. The level is reached at a high position. So there is a point measurement. In this point, if I need to measure the level, then there is a discrete measurement. That may call it as a discrete measurement. But I need the complete measurements. Then the complete probe may be act as a capacitance, and complete body may be act as another plate of the capacitance, so that the continuous measurements, the changes in the dielectric medium, that means water level increase, which causes the changes in the dielectric medium, right? So between the gap between the two plates is affected by the filling of the liquid. So the dielectric medium is changes. The corresponding changes will be observed, the corresponding changes in terms of electrical quantity, and we just correlate in terms of electrical output, and which is directly proportional to the height of the liquid tank. That is the basic principle. So the basic principle of capacitive level measurements, which is based on change of capacitance. So that is the basic concept, right? Once you know the basic physics of the capacitance, then you may use those capacitance principle to different applications. Even you can able to measure. I mean, for an example, if you are using going to measure the pressure by means of a diaphragm or maybe bellow gauges, right? Well, when pressure is exerted in the bellow gauges or diaphragm, what happens? It get displaces. So we may consider that diaphragm is one plate and another maybe another plate. So distance between the two plates is changes when you apply the force or pressure. Then there is a capacitance changes causes in terms that may be correlated in terms of liquid, pressure. Here the dielectric medium may be changes, or in this case also here we have used we may use some float overage. So when the water level is increased, float may be also raised. So which is connected with either diaphragm or a bellow gauges. Then those things will be act as one plate of a capacitor, and the body will be act as another plate of the capacitors, and distance between the two plates capacitor will be changes, causes the changes in the electrical capacitance. So that can be correlated in terms of level of the tank. So we can either measure in continuous measurements also we can do, or point measurement also we can do by means of a capacitance level measurements. So this is an electrical method for measuring indicating liquid level in industries. The type of capacitives, either we can measure in terms of variable area type, or capacitive voltage divider method, or dielectric divider in the sense, distance between the two plates. What I said previously. So float is connected with the diaphragm. The movement will causes the movement of one plate, and another one plate is a fixed one. So when water level increases, the plate of one plate of the capacitor will be move. Then the distance between the two plates will be causes change in the capacitance. Likewise, the previous example for changes in the dielectric medium. So we can measure the water level in terms of variable area method, variable distance method, or variable dielectric constant method. And as I said, generally we may call it as an epsilon is a dielectric constant. A is the area of the plate, and D is the distance between the plates. And this is a basic principle of a capacitive type transducer. Here a simple capacitor which consists of two electrode plates, which is separated by a small thickness of insulator such as a solid or a liquid or a gas or vacuum. Here the insulator is called a dielectric. This insulator is called a dielectric. When the dielectric medium changes, it is because of the water. Then what happens? The changes in the capacitance causes the changes in the electrical output, and this is directly correlated to in terms of water level. See the animation here. See here, this is a one probe, capacitance probe, and another one will be act as a body of water tank will be act as another capacitor plate. So these are the two capacitor plates. When this is called a point measurement, there is an insulator will be provided. When it is touches with the water level, then it indicates high. When it is below to the probe, then it will be indicated as a low. It may be either used for point measurements or for continuous measurements. See, this indication which shows us a point measurements, and this indication which shows us a continuous measurements. So the capacitance type measurements can be used either for point measurements as well as the continuous measurements. So charging and discharging of the fluid will help us to measure the level of the tank. So here, this is the capacitor, plate and body is the another plate. So dielectric medium is varied when the water flow is here, then which causes the changes in the capacitance, since it's direct proportional, right? C is equal to epsilon A by D. Here I'm talking about epsilon. The dielectric medium is a water. So water between the two plates is changes, the capacitance values changes. So this is directly proportional to the height of the water tank. Height of the water tank. And what are some capacitance type having a numerous advantages? Even it has some disadvantages. Even will be discussed. It is very useful in a small systems. It's very sensitive. Since minimum variations of the water level also be measured. That is very, very sensitive type, since it is contacted with the water level. It is contacted with the water level. I mean, see here. So from the beginning itself, the probe get contacted with the water level, so that the dielectric medium is changes, so that it may be quality as a very sensitive measuring device is a capacitive level indicator for minimum variations also be measured. There are no moving parts exposed to the fluid. It is suitable for continuous indication, or even we can use for point measurements. Remote adjustment of a span 0 is possible in this level of indicator, since the indicator is outside. So this is an indicator. So we can adjust the 0 and span level, since even if we have direct measurements with the help of side glasses, then we cannot do any span or 0 adjustments. So here the electronic instruments which is provided outside, so that we can able to adjust to the value of zeros or span, right? And it is good for use with slurries. Even we can use this for even slurry fluids, right? Not like water. Even slurries in the sense oily liquid also be measured, right? And with some muds also be measured. Sometimes in paper industries, the pulps are the slurry fluids. That means which is mixed of many woods and other particles, and that also be measured by means of this capacitive level measurements. And proof materials for most corrosive fluids are available. And some disadvantages also be listed here. The performance of the capacitance level indicator is severely affected by dirt and other contaminants because they change in temperature. It is sensitive, is adversely affected by changes in the temperature. So when it is contacted with the fluid, and which is high temperature fluid, then that will be affected life or span of the measuring instruments, because temperature will affect the properties of the measurements. So in such a cases, the point level measurement is used when the temperature is high, and the point level, the capacitance probe will not be used. Instead, the capacitor may be used at outside. So there is a alternate solution in the capacitive level indicator also. And a measured fluid must have proper dielectric qualities. They usually require recalibration if measured material changes in composition or moisture content, and which is relevant to the temperature, right? And whenever the moisture content or other chemical composition is there, and that time there is a record of calibrations, right? For an example, probe is very sensitive to the temperature. You may heard about that the iron rod will, when it is inside the temperature, then it get elongated, right? Some expansion will be there, which affects the measurement of the particular parameters. So moisture content and other temperature, those things are to be considered, should be calibrated often to get an exact measurements, right? So some maintenance is required in case of liquid, level measurements, when it is complex chemical mixtures or which is reacted with the temperature. So that's a major disadvantage of a capacitive type. Another thing is a radiation type. So another method is this is also non-contact type and inferential method. So inferential method, as I said, there is no direct measurement of level. Here we are detecting the radiation. Here we are detecting, there is a detector, there is a source. So here it may be radiation, either it may be IR or it may be some other radiation. When there is no water inside the tank, then 100% of the radiation is detected by the detector. So when the water is come around here, then the portion of the radiation is blacked by the water, so that the minimum percentage is detected here. So the system get understood the level is at this position. So this is what called for a point measurement. Here or a discrete measurement of level can be done by means of a radiation type. Here we can use two radiation, single radiation sources in two different paths, which is detected by a detector. And when it is high, when it is come here, the complete radiation is blacked by the water source, so that the detector will detect very few of radiations, or sometimes it doesn't detect any kind of radiation, so that the system get understood that the water level. So based on that, they have calibrated. So when this is get blacks, then the water level is high, which indicates most of the cases this will be used for alarming purposes. When the level is high, then this detector will give the information to the controller to alarm the alarm, right? To make a sound to the alarm. So for alarming purposes or for indication purpose, these point measurements is used. Where other electrical methods would not be so almost this is widely for complex chemical processes, since when acid kind material, if is supposed to insert a capacitive probe, that get spoiled. So in such a cases, the radiation non-contact type is used. Non-contact type is used. Here also the most common reason for using this radiation level detector is that does not need to come in contact with the liquid being measured. So there is no need of any contact between the liquid as well as the sensors, sources and detectors here. You might understand, see here. So water level is increased and the portion of radiation is black, and the detector only at the beginning all the sources is captured by the detectors, and that time the output is maximum. When the level is increased, see here, when the level is increased, the detection level is reduced, and which indicates the height of the tank. So this output, which is directly correlated in terms of height of the tank. So this is, we can use it for continuous measurements, as well as if we have only two paths of radiations, either high and low, we can use it for point measurements even, to indicate to the corresponding engineers the level of the tank is high or low, right? This is a non-contact type method. So it either it may be, we can take some miniature models by means of even IRAs even. Here it consists of a gamma ray source holder on one side of the tank and a gamma detector on the other side. Not only the gamma, other radiations also be used. As I said, IR radiations will be used to measure, and based on the liquid what we are going to measure. That's the only thing, right? If it is a water, IR is enough. But if it is a slurry fluid, or if it is a complex mixture or a chemical fluids, then that time, or it is a bulk solids, that time the gamma radiation should be used to measure the level of the tank. Here, when the gamma rays penetrate the thick wall of the tank, its energy level afterwards is greatly reduced. Radiation received at gamma detector is inversely proportional to the thickness of the tank. medium between the radiation source and the detector. That is, the thicker the medium between the source and detector, the less radiation received by the detector and vice versa. So as I told, when the penetration lacks by the water, then the impulse will be reduced. So the detection will be reduced, based on which we can measure the height of the. Let me go into the next. So we'll see another micro level switches for point measurement. Microwave switches. Here, as like the radiation, there is a microwave. Instead of gamma rays, here the microwave radiation is there. Source and detector is placed. This is purely for point measurements. See here, it may be sources. It passes the microwaves, and the detector which receives the microwaves, and the corresponding output is in measured continuously monitored by the engineers. Right? See here, this is a water tank or tank which we are going to measure the level of the particular tank. Right? Here the source is passing the. This is a transmitter which is passing the microwaves, and if there is no, if it is a free, when there is no fluids or solid material, then it detects the 100%. The percentage of the detection will vary based upon the level of the fluid or the solids, right? And the detections will indicate the height of the measurement. This is only for, indication or point measurements. When it is fixed in the top, then it on bottom, which indicates height and low of the tank level. See some simulations, animations. Here the transmitter which passes the microwaves, which is blocked by the solids, which is filled on the tank. So this solid will be blocks the microwaves. Then it disconnects between the transmitter and receivers. When it disconnects, there is indications. Either it may be a light source or it may be alarm. Either it may. So for a monitoring purpose, when the level is exceeded, that time there may be an indications provided. So this is a kind of point measurements or discrete measurements of level measurements with the help of microwave switches. So it's a non-contact type, high penetration surface. This is major microwave generally often used for solid purpose measurement of the solid level on the tank. For an example, for making we consider for a paper industries, the wood are crushed in first to make a powder particles. That time the solid particles come into the crusher. So the crusher level should be monitored, and when the solid particles will blocks the microwaves, then which indicates the level of the crusher in the paper industry, and up to that the filling was there. Once it is indication done, then the filling was stopped, and again it will be continue after removing the powder particles after the crusher, right? And this is majorly, even it may be used for water, liquid also, and solids. High penetration surface coating immunity, simple installation setup, very simple in construction. Total safety for operators and site personnel, long ranges, non-invasive, wide temperature ranges, even for temperature affected fluids also we can able to measure, since microwave doesn't last by means of a temperature. So that's about micro level switches. Major applications are quarry, water and waste to process like chemicals, pulp, paper industries, and mining. These are all the different applications of the microwave switches. And next is the optical level in detectors. So these are all the non-contact type, like previous case micro switches. See here, this is an optical type. Here the light source is emitted here. There is a path. In that path, if it is an air, then the path is regular, and the light source is detected here. Optical source is detected by means of a receiver. If it is in the air medium, when it is in the liquid medium, then the path gets disturbed and it cannot be detected by means of a receiver. This is also be used for measurement point measurements. So this is like a micro switches. So this switch is provided at the bottom and top to indicate the high and low level indications of the tank. Here, optical level detector make use of visible or IR rays, also be infrared light beams to detect the level of the liquid or solids. A beam of light is aimed at the liquid or solids level, is reflected back to the light sensitive transistor located in the same holder as the light sources. So when the light sources is there, there is no liquid or solid phases, then it will be passes and it will be detected by means of light detectors. See here, there is a light detector. So light sources is passed and it is detected by here. Rippled. This is another kind. Light source is there, and which there is no medium inside. There is only air medium. So when it passes and it is fell on the either side, and which is reflected to the light sensors. So sources, there is no liquid or solid particles, then it may be reflected and 100% of the light source is directed here. When there is a solid or liquid particles present inside in between this, then what happen? Light source path is disturbed and the light source cannot be detected by the light senses. So that we can understand that maybe disturbances occurred due to that level of the water or a solid. So which may gives an indication to the alarm or light sources to engineers. So these are all the point measurements of level, right? Optical level indicators. So next is ultrasonic that we discussed earlier also. Ultrasonic, there is a ultrasonic source which generates the sound wave, and the sound wave is also non-contact type. Non-contact direct level sensor level is a function of the time it takes an ultrasonic pulses to hit the surface and return. So here what happened, this is a transceiver. Transceiver is nothing but it can able to transmit and it can able to receive it. Both can be done by a single device called a transceiver. So ultrasonic transceiver is provided at the top of the tank. It's a closed tank. So at the beginning there is no water inside. Then what happened? The distance travel between the sound wave is high and it can be reflected and it can be detected. So the time is calculated. That's so called time of flight. And when the liquid is coming inside to the tank, the level is increased, then the time between the transmission and receiver will be reduced, and which indicates the level of the tank. So the corresponding electrical output, which is correlated in terms of liquid level of the tank. So this is what called non-contact type ultrasonic level detector. So surface foam absorbs signals, agitations which creates reflections, high pressure and high temperature affect the signal speed, vapor and condensate create the false echoes. Right? So if it is a vapor, it can be used for solid and liquid, and if it is a vapor, then there may be a fault indications will be provided. And if it is a condensate, will create some false echoes, so that the reading will be differ. These are some limitations of the ultrasonic type of device, level indications. So which operate on the basic principle of using sound waves used to determine the liquid, solid or slurry's level or distance. So here what we are measuring the distance travel between the sound waves. Well, after hitting, how much time it takes to reach the receivers. So the time is calculated and which is correlated in terms of level of the tank. A sensor would normally be mounted at the top of the tank and direct a sound wave down towards the surface of the product. When the sound wave hits the product, it is reflected and returned to the sensors. The greater the distance between the sensors and the product, the longer it will take the sound wave to travel down and back again. So what I said, so when there is no liquid, then it takes long time to hit the bottom and to receive the, to receive by the receivers. If the level is increased, that distance between the water level and that sensor is decreased, the travel between the sound wave will also be decreased, so that we can get the corresponding electrical output, which is correlated in terms of a level. So these are all the non-contact type or indirect type level measurements. We can measure ultrasonic level detectors using for point measurements as well as the continuous measurements. So time of flight, time travel from the a source and which is hit by the phase of the liquid or a solid, and which is revert back to the sensor or transfer. This time is calculated, the sound wave is calculated. Correspondingly, we get the electrical current output. These 4 to 20 milliamps is the standard output of a current which is used in the industries. 4 to 20 milliamps. Here 4 is so called live zero, 20 is maximum. So the receiving output is calibrated in terms of 4 to 20 milliamps. The corresponding 4 to 20 milliamps will give the level of the tank. Either it may be 0 to 100 meters or centimeters, whatever it may. So based on the measurements, it may be the output current is calibrated. See here. So when the level is increased, the distance sound wave travel is reduced. So corresponding output is recorded, and this is correlated in terms of a level. So some advantages of non-contact measurement techniques: they have ability to measure the level without making physical contact with the process material. They have no moving parts. The reliability of the reading is unaffected by changes in the composition, density, moisture content, electrical conductivity, dielectrical constants of the process fluid. Some disadvantages: temperature compensation is essential in ultrasonic level measurement. Since when temperature also be there, then the process output will be, the sound wave will get lost. So the temperature compensation is required. The dirt and irregular and slope surface affect the accuracy of the measurements. If the tank is a conical, or a different shape or irregular shape, then the filling of the material also be irregular. That time the level indication will not be good. It will not be proper, right? An ultrasonic transmitter is subjected to many interferences which affect the strength of the echo it receives. The echo can be weak due to the dispersion and absorption. So sometimes the liquid or a material which we are going to measure the level, and that can absorb some amount of echoes. So the liquid we are going to measure should be should be free from the absorption of the sounds. So those are the major disadvantages of the ultrasonic level detectors. So thank you all. Is there any doubt, you can ask me now. I think you might understand.
If you have any queries, please ask now. Any queries or any clarification if you need, just raise it now. Either to chat box or you can unmute your voice. Okay. So shall we wind up?
Yes.
Okay, sir. So once again, thank you so much for sharing your valuable time with us. The two sessions were very informative and just an easy way of explanation regarding the matters. So thank you, sir. Thank you so much for your presentation and guidance.
Thank you for giving this opportunity to me also. I'm
Oh.
thanking you as well, the Jyothi team also. Thank you.
Thank you, sir. Thank you so much.
Thank you.